standard way.
Where'd that
I
come
assume
from?
we're gonna get the same answer.
Where'd that come from?
Well, is it supposed to be plus plus or is it supposed to be minus plus minus?
It is supposed to be a minus right there. Thank you for that. First thing is, Dr. Thomas and I both agree those two are the same. If I told you to prove it as the same, what would you do? Yeah, just work them out, right? They're the same, guys. Now I want to know where that second one comes from. The middle row. The first one is, it's called expanding a determinant, right? And you can expand a determinant across any row or any column. Did you know that? Did you know that? You knew it because you had a real good high school math teacher, I bet. Is that where you saw it? Did you see determinants first in a math class or in a physics class?
I think it was an algebra class.
Yeah. And if you see them first in a math class, you're taught that you can expand it on any row or any column. If you see it in a physics or engineering class, they typically tell you, do it like this, which is fine. I just wanted to make the point one time for you that you can expand it along any row or any column. So what I did is I expanded it along the second row, didn't I? I went, number one, if this one's positive, this one has to be negative, right? And that's where the negative came from. And the 2 came from right there. And then I take out this row and this column. That's where the rest of it came from. Do you see what I'm doing? Well, this one was negative, therefore, no matter any direction you go in, you will alternate the sign. So that meant this 1 had to be positive. And the I and the the I and the K came because I eliminated that row and that column. I said it backwards, but you get the idea. Then that was negative, so this one has to be positive. And that's how I got there. This one was negative, this one's positive, this one has to be negative, sorry.
The second
Could you have expanded it along this column? Yes, and you would have gotten the same thing. All you're going to get here is I times a number, aren't you? J times a number and K times a number. Well, here you're going to get 1J minus 3K times a minus 2. And aren't you just going to collect terms at the end? Okay? And now, I gotta move this.
I want to let them know when they get to higher level engineering or physics courses,
Yes.
you're dealing with 4x4 things.
And 4x4s work the same way, don't they, Ed?
Right. And the reason for that is you've got 3 directions of space and 1 of time. That's what makes general relativity so much fun.
So this then is equal to, is this I times 1 minus 3 minus J times
6.
minus j times 2 plus 4 plus k times 6 plus 4. Is that right?
Why is it plus 4?
Minus and
You
minus.
do this minus this.
Okay.
So now I have minus 2i minus 6j plus 10k. And it is this vector that is the normal to the plane formed by U and V. U and V are two vectors, hence two lines. Two lines form a plane, and this is the vector that is the handle on the mortarboard. And once you know the handle on the mortarboard, then you can describe the tilt of the plane, can't you? But it is absolutely, most certainly not the tilt of the handle. But the tilt of the handle, as you rotate the handle, you rotate the plane. I spent more time on this than I needed to, particularly for people that had seen it, but I wanted you to hear it from a mathematician, and hopefully that'll help you a little bit with understanding it, as opposed to this is the way we do it.
Is there any software that will show this to the class?
My software, that software I showed you last time, probably would. I'm just not sure if I would say I'd try to do it for Monday, but I got a stack of test papers. I'll play with it and see if I can do it by the end of the semester. One last thing is U cross V what's a parallelogram?
Two sets of parallel lines.
Is it like a square?
Yeah, two sets of parallel lines. Very good. The four lines parallel to the length, and 1, 2, 3, 4 lines parallel to the width. How about if it's a box that somebody stepped on? Imagine I've got a box right here, and I stepped on the top of it. Wouldn't it collapse in one direction or the other? That's what a parallelogram is. And in a plane, if the surface of this is a rectangle in a plane, when I step on the box, doesn't this surface quit being at 90 degrees and start being at some other angle? Okay. That's used every now and then in development of theoretical problems. Then now doing this from memory and I'm gonna look. Oh, yes it is.
No, it's
Wait a minute, Ed, I'm spelling low pid. I have to concentrate, I don't have to concentrate on math, I have to concentrate on spelling.
parallelepiped.
Yeah, pipette.
We don't do that in Math 98. We just call it a rectangular box.
Parallel,
Parallelepiped. I don't know if an O goes in there or what.
P-I-P-E-D.
Yeah. Formal name.
What's the parallelepiped? Look, it's this box after I stepped on it. It's when the walls break down and it looks like that on the side. It is a rectangle. How about if we say it is a rectangular solid? Is that what this is? With angles other than 90 degrees. Would that describe it? Every angle on this is 90 degrees, huh? Okay. I just covered 12.4. And that's enough for today. We'll quit. I'm going to go as far as I can, as far as time will allow me to go in chapters 12 and 13. I won't get much into 13, but that's okay. What Dr. Freelow will do in Cal 4, he's going to start out with, I think I remember that starts out with partial derivatives. And then the whole second portion of the course is vector calculus, and chapter 13 is baby vector calculus. So where I'm headed is, I don't feel like I have to get too much in there because he's going to cover it as he teaches you the real stuff. Okay?
Who's taking Cal 4 this summer?
Are you?
I'm doing it in the fall.
Travis, you're not?
No, I'm doing it in the fall as well.
I'm probably going to try.
There,
I'm probably going to try to take it in December.
it's on the schedule for Freelove this summer. If I were the dean, which by the way, I'm not, don't want to be, and wouldn't have it, I wouldn't put it this summer. Because I knew this had happened. What's going to happen is there are 5 people in this class, and 2 of you will take it in the summer, and 3 of you will take it in the fall, and that's 2 very, very small classes. And it would have been better if everybody had just taken it in the fall and we'd have stayed in the 4-block rotation. But given that it's offered, I don't blame you guys for getting it out of the way.
Are there going to be any students coming up from the other?
No, see, Cal 3's not being offered in the summer. And you're not going to take Cal 4